ठीक है. So till now we have seen different types of steel structures. We have also seen the steel connections, different shapes, then classification of cross sections, and slowly we have gone into the details of bolted connections. As far as bolt connection is concerned, we have also came across various types of bolted connections, and not only the types, but we have also seen the classification of bolted connections. So depending on the load transfer mechanism, depending upon the type of joint or type of connection, so on. And we have seen the various components of bolts, like the head, threaded portion, shank, then washer, nuts, etc. Isn't it? And along with that, we have also seen various grades of bolt. These grades of bolt will be required in our calculation purpose. Today I am going to start the numerical aspect of the connection. So it is requested to all that you please take out your notebook, pen, calculator, etc. And you are supposed to prepare your own notes. Okay, although I have written many more things, but few things I have skipped purposefully so that you people should write it. Okay, so take out your notebook, pen, calculator, and let us see what are the various aspects as far as bolted connections are concerned, because we have seen the classification of bolt connection, and in that classification we saw that there are different types, like the lap joint, then the butt joint, etc. Okay, so for lap joint, if I want to understand what exactly is lap joint, so can you see this connection? This is a bolted connection. Typical over here, you will find that there are two plates which are connected, and you can see this dotted connection. Dotted connection in the sense uh, there are two more plates which are below this plate. Okay, below this complete plate, there are two plates which are connected in this manner. So such kind of connection is your butt joint, isn't it? This is a plan. This is the plan of the butt joint. And in the elevation, you can understand that this butt connection is something of this sort. Okay, over here, how many number of bolts do you observe? In one connection, you have two number of bolts. Okay, so whenever you are defining any butt type of connection, either you discuss about left hand side or you discuss about right hand side. So total number of bolts in a connection are two numbers. Okay, so we will see to it, but this is typical representation of a joint connection, you can say. Okay, and this is butt connection. When we connect two different members, like for example, you can see over here. What do you see? What is this? This is a vertical member, agreed, and this is horizontal member. And you can say that this connection, whatever is been done with the help of two different members and with the help of bolts, this connection is nothing but beam column connection. Don't you feel so? This is beam and this is column connection, right?
Yes.
And if you see the elevation, rather the side view of this connection, what do you observe? This part. Okay, so this is the side view of this connection, and you can understand that this part is only this portion is shown over here, correct? How many bolts do you observe? One, two, three. Okay, on the other side similar connection is provided, and the cross section of the beam is I section, and the cross section of this column is again I section. Moreover, you will find this hatch portion. This hatch portion is nothing but the weld. So there is a combination of welded connection as well as bolted connection, which forms the moment resisting type of connections. Okay? So we have also seen what are the moment resisting type of connections. Here, this is a typical connection which will in which the bolts will experience tension as well as shear. And what makes the bolts experience the tension force? The horizontal component of the force which will be transmitted in this diagonal member, that will create tension force in these bolts. Agreed. And to balance, to counteract the vertical shear force which is developed because of the end support, those will be balanced by the shear force which will be developed between these connections. Okay. The purpose of showing all these things is typical fabrication drawing is represented in this manner. Okay, so the draftsman, what the draftsman does, the draftsman will draft all the details in this manner so that each and every component is crystal clear for the supervisor to understand, so that the fabricator on site will fabricate the things and the complete structure will be standing with the help of these drawings. So these drawings should be as clear as like what is shown over here. Okay. Next, there are few IS code clauses which we need to understand, which we need to take care of, and you will see that most of the time in competitive exams and also in our practical and theory exams, you will find the IS code clauses for bolted connections. Those becomes very important part, and they are frequently asked. So let us try to revise and understand what is given in the IS code and what are the requirements for bolted connection. First is this part, maximum spacing. So this is clause number 10 or section 10. In this clause number 10.2.3, it says about the maximum spacing, because you can see the bolted connections whatever are placed, there should be some standard based on which the spacing between the two bolts, those two to be defined. Otherwise we cannot keep the bolted connection in any manner, any haphazard manner. There should be some standard guideline based on which the center to center distance should be defined. Okay? So that is known as the spacing. So maximum spacing criterion is mentioned. What it says, the distance between centers of any two adjacent fasteners or bolts shall not exceed 32 times small t or 300 mm, whichever is less, where t is the thickness of the thinner plate. C. Any connection will consist of two or more plates, and it is not necessary that the thickness or the size or the dimension of these plates will be the same. Some may be thicker or having a larger thickness, and some may have smaller thickness. So we are supposed to consider this spacing, whatever spacing is mentioned over here, uh, that to be 32 times t, small t, or 300 mm, whichever is less. This t is nothing but the smallest thickness or thinner plate thickness, right? Then the distance between the centers of two adjacent fasteners, which is known as pitch, in a line lying in the direction of the stress, shall not exceed 16 times t or 200 mm, whichever is less. And t here stands for thinner plate only. Okay, in tension members and 12 times T or 200 mm, whichever is in compression member, where T is the thickness of the thinner plate. Just try to understand the definition of this term, which is known as pitch. According to IS code, it says that this pitch distance is nothing but the direction or the spacing between two bolts, center to center distance between two bolts, which is parallel to the direction of the stresses developed, or which is in line with the stresses developed. So just try to understand if this is a connection. These are the bolts which are placed. Okay? And if this connection is provided force in this direction, one end is, let's say, fixed and the force is applied in this direction, the stresses will be developed in the same direction. Let me tell you with the help of this. If I'm applying force in this direction, okay, so naturally these stresses which are developed, they will be again in this direction, correct? So as per your IS code, this distance, if the connection is like this, and you are supposed to define the distance, center to center distance between these two bolts, if this center to center distance between bolts is parallel to the stresses which are developed, then it is known as pitch. Got it? So for tension members and for compression members, these spacings are to be followed. Okay. In case of compression member wherein forces are transferred through butting faces, this distance shall not exceed 4.5 times the diameter of the fasteners for a distance equal to 1.5 times the width of the member from the butting face. Okay. Our main understanding should be up to this, because this is a typical case, okay, which we will not discuss right now. The distance between centers of any two consecutive fastener in a line adjacent and parallel to the edge of an outside plate shall not exceed 100 mm. Distance between centers of any two consecutive fasteners in line adjacent and parallel to an edge of an outside plate shall not exceed 100 mm plus 4 times T or 200 mm, whichever is less. In compression and tension members, T is the thickness of the thinner outside plate. So this is again a typical condition. I will be discussing it later on. Our next part is edge and end distances. Okay? This edge and end distances, this part is very important for us to understand, because if you say edge and end, both these things, both these terms are more or less same. But as per IS code, the edge distance is the distance at right angles to the direction of the stress from the center of the hole to the adjacent edge. कहने का मतलब है, if this is the direction of the stress, okay, if this is the direction of the stress, the edge distance is the distance at right angles to the direction of stress from the center of the hole to the adjacent edge. That means this will be your edge distance. Okay, this distance is actually perpendicular to the direction of the stress, isn't it? Because stresses, as you can see, they are in this direction. Fine. So this distance is known as edge distance, whereas the end distance is the distance in the direction of the stress from the center of hole to the end of the element. That means from here to here. This will be the end distance. Have you understood the difference between edge and end distances? In case of edge distance, the distance from the center of the hole, it may be this hole also. So from the center of this hole to the edge, which is perpendicular to the direction of the stress, that will be your edge distance. And the the what end distance will be this, from the center of the bolt hole to the adjacent end, which is in the direction of the stress. Okay, so these are the definitions of edge and end distances. Then this is again a typical case. I will discuss it later on. So I hope you have understood the basic understanding of edge and end distance, right? Is this okay? Because this will be required. Is this fine? Shall we move ahead? Yes, please let me know. ठीक है. Next is minimum edge and end distances from the center of any hole to the nearest edge of a plate shall not be less than 1.7 times 1.7 times the hole diameter in case of sheared or hand flame cut edges, and 1.5 times the hole diameter in case of rolled machine flame cut, sawn and planed edges. So what happens? There are different methods in order to prepare the uh, edges. Sometimes they are hand flame cut, ठीक है? Sometimes they are rolled machine flame cut. So there are different methods which are adopted. Depending on those methodologies, IS code defines the minimum edge distance which has to be taken, which has to be considered initially. Okay, so unless and until we don't know the method of edge preparation of the plate, we are supposed to assume the minimum edge and end distances to be either 1.7 times or 1.5 times. Okay, is this okay? Because we will require the reference of this minimum edge and end distances whenever we will be solving any numerical. Okay, is this okay? Let us see the application of this, all these clauses whatever we have discussed right now. Okay, this is the description of whatever we have discussed. Now we will begin with simple numerical so as to understand what this bolted connection is all about and how it can be done. Okay, so to begin with, let us try to understand. We will start with the calculation of the capacity or the strength of any type of connection, and slowly we will see that how to design that connection. So are you ready? So you please uh, take down the solution. Also you can take down the problem statement, and what it says in this problem statement: calculate the strength of a 20 diameter bolt of grade 4.6 for the following cases. The main plates to be joined are 12 thick. So in this numerical, the thickness of the plates which are to be connected, those are given. And here, as you can read, here there is a mention of single bolt, as you can see over here. Calculate the strength of a 20 diameter bolt. Grade is also mentioned, and there are different cases, different connections based on which we are supposed to calculate the strength for each type of connection. So let us see what are the different connections which are mentioned. First is the lap joint. Second is the single cover butt joint, and the cover plate over here is 10 thick. Third is double cover butt joint, each of the cover plate being 8 thick. So we will go case wise. Let us consider case number 1, which is lap joint. So as you know, how is the lap joint? This is this lap joint connection. Okay, simple lap joint. Okay, and this lap joint is connected with the help of this bolt. So as you can see, I have drawn the vertical lines, these two vertical lines. This is what? This is nothing but the bolt hole. Okay, and the purpose of the bolt hole is to make the passage of the bolt clear in order to insert into the connection. Later on, that bolt is then fixed or fitted with the help of this nut in order to make this connection tight. Have you understood this figure? This is the elevation, and this becomes the plan. So in this plan you can see I have shown the bolt hole. This is the top plate, and this one is the bottom plate. This bottom plate is represented with the help of dotted line on this side. Since we are looking from the top, this will be visible. So is this view clear to all? Please let me know before I proceed. ठीक है. Now, the most important thing which you people are supposed to remember, we are supposed to write down all the necessary information which is given in the numerical. So to start with, we have this information, that is grade of the bolt, the diameter of the bolt, the thickness of the plate. Let's go step by step. As per IS 800-2007, page number 13, 13. Okay, what is given? What is given on page number 13? Please let me know. So it is expected that you people should also keep your IS 800-2007 open. So can you please open page number 13 of IS 800, please, and please let me know what is given on page number 13. Yes. Hello. Hello. Is it visible? Is this visible? Okay. So just let me know what is given on page number 13, 13. So जिन लोगों को ये चीज नहीं मालूम है, प्लीज गो थ्रू द डेरिवेशंस. ओके, जो भी स्टैंडर्ड. Yes. No. No, टेंसाइल प्रॉपर्टी नहीं है. क्या दिया है एग्जैक्टली वो उसका डिस्क्रिप्शन क्या है पेज नंबर 13 पे क्या दिया हुआ है? यस, टेबल नंबर. व्हाट इज द टेबल नंबर 1? ठीक है. सो in addition to this page number 13, you are supposed to write down table number 1. You please note down. I have told you that I have written most of the things, but I have skipped few things in order to make you people understand what is the required term. That is very essential. Huh? Sorry. Table number one. वो लिखो आप. Fine. So for grade 4.6, you please write down for grade 4.6, FU is equal to 410 MPa for plate. So from where did you get this? FU equal to 410 MPa. Is it given on page number 13? Yes. Is it given on page number 13? No, it is not given on page number 13. बताओ कौन से पेज पे दिया है? Fine, just look here. It is requested that please make a habit of referring IS code. It is very essential. ठीक है, ये देखो. Are you able to see this? Table 1 tensile properties of structural steel products. ठीक है? Over here, yes, now you can see. Table 1 which is concluded on page number 14. See, what is the grade of plate which is mentioned? Do we have anything, any information related to grade of the plate? Is it given? Yes? Yes or no? No. That is grade of the bolt. I am saying grade of the plate. Nothing is mentioned, isn't it? So in such cases where the information related to the grade of the plate is not given, you are supposed to assume the grade of the plate to be this one. Fe410. Okay? You can consider any of this. Fe410W, A, B or C. Okay? Is this fine? And after assuming this, you will see the grade of the ultimate tensile stress which is given in MPa. What is the value for all the three grades? You can see it is 410. Is this clear? You can assume anything, any of these three. So let us for this example consider, you can write down assuming Fe410WA to be the grade of plate. And after assuming that, then you note down the value of ultimate tensile stress. What it stands for? F suffix U. F suffix U, which is 410 MPa. Okay. Next, FUB. For the ultimate tensile stress of bolt, I have represented this as FUB. Okay. This has been obtained from, again, page number 13 of IS 800. तो ये देखो 4.6 ग्रेड लिखा हुआ है यहाँ पे. Can you see this? 4.6. And for that, what is the FUB value? It is 400 MPa. Am I right? So jot down all these values. Next, we have discussed about the partial safety factors. If you remember, we have also understood the purpose why partial safety factors are to be used. Then, from where I will be getting this partial safety factor? from table number 5, which is given on page number 30. Page number 30, table 5. So jump onto it, page number 30. Over here, you will observe the description is given. No? The description. Now you can see bolts. Fine. The resistance of connection, bolts, friction type, bolts, bearing type, rivets and welds. We will be assuming bolts to be bearing type. Okay, and the notation for that bearing type bolts is gamma MB. Okay, and what is the partial safety factor value? So there are two conditions. One is for shop fabrication, another one is for field fabrication. Fortunately, both these values are same. In our numerical, nothing is mentioned whether it is shop fabricated or on field it is driven. So you can assume anything. Okay. So while assuming, you please mention. So you can write down assuming the fabrication to be on the field. You please write down assuming the fabrication to be done on the field. Based on that, gamma MB value will be 1.25. So have you understood this thing? Yes, please let me know. Have you understood this part? देखो इनिशियल लेवल पे ही मैक्सिमम इंफॉर्मेशन आप लोगों को लिखना है एंड व्हाइल राइटिंग यू आर सपोज टू supplement your values with the help of the references of IS code. I hope this is understood. Shall we go ahead? ठीक है. Then for first case where the bolt is in single shear and bearing. So I have written this statement. For case 1, that is this case, the bolt is in single shear and bearing. Why I must have written this thing? Let's recall our discussion related to the shear planes, which may be there based on the type of joint. In case of lap joint, and that to such kind of lap joint wherein only two plates are connected, how many shear planes do we observe? I have told you one formula, if you remember. To find out the shear planes, number of shear planes, the number of shear planes will be equal to number of plates connected minus 1. Okay? So over here, the shear plane come out to be 1, since there are two plates. And therefore, the bolt will be subjected to single shear and bearing. Bearing effect का मतलब भी मैंने बताया आप लोगों को कि when this bolt surface will come in contact with the surface of the plate based on the external loading, at that time bearing forces will be generated. Fine. So for case 1, bolt is in single shear and bearing. Therefore, the strength of the bolt in single shear we are now supposed to identify. we need to check what is the exact strength of the bolt in single shear. For this, you will find one formula which is given in your IS 800 2007. For this, you please refer clause number 10.3.3, which is given on page number 75. I will discuss this. Page number 75. ठीक है. So fine, what it is written, a bolt subjected to factor shear force shall satisfy the following condition. BSB is equal to BD, VDB, where VDB is design strength of the bolt taken as smaller of the value as governed by shear and bearing. Okay, this VDB is smallest, least of VDSB and VDPB. VDSB is nothing but the value which is governed by shear, and VDPB is nothing but value governed by bearing. The shear capacity of the bolt, that is nothing but the design strength of the bolt governed by the shear, is given by VDSB is equal to VNSB divided by gamma MB. Okay, this is further simplified in this manner. VNSB is equal to FU divided by under root 3 in bracket NN into ANB plus NS into ASB. That is nothing but stress into area will give me the value. But while finding out this, we are supposed to consider these additional terms, that is n suffix n, n suffix s. What are these? Let's try to understand. Nn is number of shear planes with threads intercepting the shear plane. Number of shear planes with threads intercepting the shear plane. Ns is number of shear planes without threads intercepting the shear plane. Okay, so these two things are to be understood. So Nn मैं फिर से पढ़ता हूँ, it is number of shear planes with threads intercepting the shear plane. इसका कहने का मतलब ये है, see what happens. Our connection is something of this sort. ठीक है, and this is the bolt. Let's say this is bolted connection, and what happens is this is the yeah, this is the plane. Green line is a plane where the bolt may experience shear. Do you agree? This is that plane. In our situation, this horizontal green line is the plane where the bolt may experience shear. Now, as per NN value, what it says that if this plane is consisting of the threaded portion, if it intersects the threaded portion, then that value has to be considered, or then the NN value will come into picture. Okay, so we will be considering the threaded portion like this. Okay, and based on this, you will find that this shear plane is intersecting the threaded portion both on the top side and the bottom side. There may be some cases wherein you will find, for example, this case, this one. यहाँ पे देखो, ये जो है, this is shank portion. Okay, from here to here, this is shank, and from here, let's say the threaded portion it starts. Okay, so let me represent that. So this is the threaded portion. Okay, fine. So let me know first of all How many shear planes do you observe in this case? Two, isn't it? So this one may be the first one and this is the second one, correct? If I consider this second shear plane, as per our discussion, you can see that this shear plane is intersecting the threaded portion, and because of which NN value will come into picture, isn't it? Whereas if I consider this shear plane, do we have any part of thread which is getting intersected by this shear plane? Yes or no? No, isn't it? And therefore, over here, the NN value will be 0. Whereas, what it says for NS, what does it says? Number of shear planes without threads intercepting the shear plane. So over here, this shear plane, which doesn't consist of any, which is not intersecting any thread, okay, that will become your NS value. And therefore, you will see that in this case, in this particular case, the NN value is 1 and NS value is also 1. But in our case, as you can see what I have shown, the threaded portion is getting intersected by this shear plane. So what do you anticipate will be the value for NN? कितना हो सकता है NN in our case? 1. And what about NS? 0. Exactly. Okay. So have you understood this difference? Because this is necessary to understand. So you are supposed to consider, unless and until, देखो ये बहुत important है, unless and until it is mentioned or such figure is given, such condition is given, unless and until the case is, you are supposed to consider the value of shear planes or the shear planes to be intersecting the threads. ठीक है? So that we can eliminate this NS term, unless and until it is given. That will be based on the condition. I hope this is understood. ठीक है? Then there are few more terms associated to the calculation of strength of the bolt in shear. That is nothing but VNSB. Let me discuss those. देखो, Fu is the ultimate tensile strength of, यहाँ पे bolt लिखा है उन्होंने, ठीक है, ultimate tensile strength of bolt, and since it is ultimate tensile strength of bolt, I have represented it as FUB in order to avoid confusion. यहाँ पे although it is written as FU, you can consider it to be FUB. Okay. Then sometimes this VNSB value, it varies depend on various other factors like the type of joint. If the joint is long joint, in that case, IS code has specified this formula, and this has to be multiplied to calculate the final VNSB value. This formula is BLJ, beta LJ. LJ is the long joint. Okay, and this is the formulation which is given. One thing. Second is the large grip lengths. It depends upon the grip length value. This is the beta LG. This is the term which is given. And third, which is very important, is the packing plates. Sometimes there is a requirement of packing plates also. We will be discussing this packing plate condition. Okay, and based on that, one more factor is to be multiplied in this equation. So ultimately, this equation actually will look like this. It will be VNSB will be equal to FUB divided by under root 3 in brackets NN ANB plus NS ASB into बीटा एल जे, ये आई जे नहीं है, दिस इज एल है, एल जे, बीटा एल जे, बीटा आई जी, बीटा पी के, ठीक है. So I have written, unless it is mentioned, any of the conditions अगर mention नहीं है, what you are supposed to do, you are supposed to consider all these values to be 1, and therefore this formula will reduce to only this part. Is this okay? ठीक है. Now what we will do, slowly we will substitute the values of FUB, NF, ANB, NS, ASB. So as we have understood for our case, NS was 0 and therefore this product is 0. ठीक है. Now we will try to identify NN. NN is 1 as we have discussed. What is ANB? ANB is net shear area of the bolt at threads may be taken as the area corresponding to the root diameter at the thread. This is very difficult to understand. How to calculate the root area at the thread, root diameter at the thread. So, what is done? This value of A and B, okay, is calculated, and that calculation is what is the value of pi d square by 4? Can you please calculate area of the bolt? What is the diameter of the bolt given? 20 mm. ठीक है. So can you please let me know what is the value of pi d square by 4? D is the diameter of the bolt. Yes. Yes, can you please let me know what is the value of area? 314, isn't it? So this A and B, as per definition, as you can see what it is written, net area of the bolt at threads. It is very difficult to identify, right? So what is done? Whatever area you have calculated, how much did it come out to be? 314, no? So this value of A and B, you can note down. The value of A and B is considered as 0.78 times the area of the bolt. 0.78 times. This value has been identified based on several experimentations. Experimentation in the sense the calculation is done. The measurement was carried out for various samples, and based on that one value was identified, and this value actually it ranges from 0.78 to 0.8 times the area of the bolt. Okay, so we will be considering 0.78 times the area of the bolt in order to calculate A and B. Is this okay? ठीक है. So by that I think you will get this 245 value. ठीक है. So fine. So this is okay. You calculate this VNSB value. VNSB is what? The strength of the bolt in single shear, and based on that we are now supposed to calculate the VDSB value, that is the design strength. What will be the design capacity? Okay, so VDSB is equal to VNSB divided by gamma NB, that is given over here. ये देखो, VDSB is equal to VNSB divided by gamma NB. So you can check this value. I think this value comes out to be this one only. Okay, you can verify that. Then we are also we should also actually check the strength of the bolt in bearing. That means If the case that the bolt will come in contact with the plate, what will be the value? Whether this value is governing or critical, rather whether the shear will come early or the bearing effect will come early, that's what we are supposed to verify. And remember, you are supposed to uh, delay the bearing process. Okay, we should not allow the bearing process to be at the early stage. Okay. So we will see in the next class how to evaluate the bearing capacity of bolt. There are many more terms, and hence I will be explaining you these terms in the next class. I hope you have understood the discussion, right, whatever I have done till now. Is there any kind of difficulty? You can please ask. We can discuss and sort out. Do you have any difficulty related to the calculation of VDSB? Have you understood the NN and NS terms? Is this clear? Okay. So fine. We will be discussing the strength of the bolt in bearing in the next class. So I will stop here. Thank you.